Hey everyone, what I want to talk about now is how the CT scanner sends a study to PACS. And we've been breaking DICOM down into its individual components and how this thing works and how this thing works. Now I want to assemble all those ideas back together into one concept about how a study gets sent to PACS. So the first thing that happens is the CT scanner requests to establish a DICOM association with the PACS DICOM server. It sends an association request message, which basically says, hey, I've got images to store. Can you take these images, and what transfer syntax would you like to use? PACS DICOM server grants an association to the CT scanner. It does this by sending an association response message. It says, yes, I can store your images, and let's transfer them by implicit big endian. So then the CT scanner sends a CT store service request to the PACS DICOM server. Okay, I am ready to store the images now. I'm going to send them to you. The PACS DICOM server receives the CStore request and issues a CStore response. Okay, yes, I can now take your images in. Step 5, the CT scanner now sends the first data packet of the first image to the PACS DICOM server. Remember, the whole image doesn't get transferred out once. In most cases, the image gets broken down into 9 sections. So packet 1 of 9 gets sent to the DICOM server. PACS DICOM server performs the requested CStore service to store that packet, and when it completes the CStore, it sends a confirmation to the CT scanner, yes, I have stored the first packet of the first image, is what PACS will be saying. Step 7, okay? We're on step 7, and we've stored 1 packet of the first image. After receiving the confirmation from the PACS DICOM server, the CT scanner sends the next packet. And this process repeats until all the packets, all 9 packets, have been transferred to PACS. We're on step 7. If we typed all that out, it would be on like step 25 before we got all 9 packets across. So again, put this in the context of the packets are going on one channel and the conversation back and forth. Did you get it? Yes, I got it. Send the next one. Okay, I sent you that one. Did you get it? Yes, send it. It's going on a second channel. That's why move is faster. If it's a get, it's only one channel. It can't talk and move packets at the same time. So the packet comes over, then the talking happens, then the second packet comes over, then the talking happens. That's why get is slower. So from step 7 comes step 8. The CT scanner issues a second CStore service request to the PACS DICOM server for transmission of the second image. Okay, this is an important point. Every image gets its own CStore service request. There's a CStore for every single image. Now think about this. CT scan of the abdomen, 300 images. There's going to be 300 CStore service requests from the CT scanner to the PACS because every image gets its own CStore service request. The PACS DICOM server issues a CStore service response message, and then that whole packet transfer process repeats. Then they do it again for the third image. And the process repeats until all the images have been transferred to PACS. So when we say DICOM connections are slow, it's because of all of this process of talking back and forth and moving all these packets to create whole images. That's why a DICOM connection is slow. That's why when people click on a link that brings up a DICOM image, we're not just pulling a JPEG quickly across the TCP/IP connection. We're pulling it through a DICOM connection. All of this discussion has to go back and forth between the workstation and PACS to pull it out, or between the CT scanner and the PACS to get the images in. And then there's step 9. After the last packet of the last image has been confirmed as stored by PACS, the CT scanner sends a drop association request. PACS sends back a drop association response, and then the association is terminated. All right, so here's step 10. The drop association message goes out, both sides terminate. This is a visual representation of that whole process, the image transfer service loop. That's how DICOM sends, and that's how chatty a DICOM connection is. That's why move is faster, because it uses 2 channels, and that's why it takes a long time to move images from one place to another, because of how complicated and complex this type of connection is. Thank you for watching.